Suppose you get this integral. The integral of x over 2 minus x and 3 plus x dx. Well, you don't really have a straightforward method to integrate this as it is. Now, what you'd have to do is break it up into two parts so that you have a number over 2 minus x, and separately you have a number over 3 plus x. Right? Now, if you had a number over 2 minus x, for example, for argument's sake, say 1 over 2 minus x, to integrate, then what you would have, you could do it by, you could do this integration by substitution. So let u is equal to 2 minus x. So what you would have is the integral of 1 over u dx. But if you say du by dx for this, it would be what? Negative 1. So dx would be du over negative 1. We just negative du. So let's change dx to negative du. And negative 1 du, which is like negative 1 over u du. And this would be ln u plus c, negative ln u plus c, right? Which would be the same thing as negative ln 2 minus x plus c. So you could integrate this if you had a number over 2 minus x. But what that means now is that you have to find this thing in the form of a number over 2 minus x plus a number over 3 plus x. Now, let's see what's going to happen. X, what we're going to do is break this up into its partial fraction, or what they call decompose into partial fractions. All right, so x over 2 minus x, 3 plus x. Now the partial fractions of this will be in the form a number, whatever that number is. Let's call it a, uppercase a, over 2 minus x plus another number, call it uppercase b, over 3 plus x. It will be in that form, right? There are standard forms that partial fractions take, and with this, where you have two linear factors multiplied in the denominator, it will be in this form. Now, what do we do? All right, so first of all, we have for the steps when we deal with this kind of thing. What we do for step 1 is to have it in the form a over, say, x plus a plus b over x plus b, whatever those are. You write it in the form a over one factor plus b over the other factor. All right? Now, the next thing, we're going to multiply by the complete denominator by 2 minus x, 3 plus x. All right? So that is our next step. Step 2, multiply by the denominator. That means by the fraction, the brackets, I mean. Multiply by the brackets, right? The bracket with something x and something another x in it. So, what's going to happen when we do that? Let's see. We have our x over 2 minus x times 3 plus x equal, I'm going to put some space between them, a over 2 minus x plus b over 3 plus x. Now what's going to happen here? We multiply these by 2 minus x, 3 plus x, multiply each of them individually that are separated by a plus or a minus. 2 minus x, 3 plus x, and we multiply this by 2 minus x, 3 plus x. What will be the use of multiplying by these? Well, let's see. 2 minus x will cancel 2 minus x. See that? 3 plus x will cancel 3 plus x. So far we only have x equal here. What's going to happen after this? 2 minus x cancel 2 minus x. So we have a times 3 plus x plus, what's going to happen with the b now? 3 plus x cancels 3 plus x. So what we have left is b 2 minus x. See what happened there? Now, after that, we make x, we say, let x equal some number, some value. Right, or let's put number. Now, if we make x be any number we want, we'd have to solve a pair of simultaneous equations. Right, and then use any method you want, whether elimination, substitution, whatever method you want. Well, the thing is, the most convenient number to use for x is that number to make a instantly eliminate or disappear. Which number is that? What we do is make a multiply by 0. So we say, let 3x, let me write that again, let 3 plus x equal 0. That is what happened. X equal negative 3. Right? So that's the third step. Step 3 that we have here. 3. Let x equal a number, whatever number that is, but it's best if we choose a number to make a, r, and b disappear immediately. So let x equal negative 3. So what is going to happen? Negative 3 equal, we're going to have a times 3 plus negative 3 plus b times 2 minus negative 3. What happened here? Negative 3 equal 3 plus negative 3, that's 0. A is gone. And then 2 minus negative 3 is 5. So b, right, times 5. So 5b. So therefore, b equals what? Negative 3/5. So this is one of the things we wanted. After that, we want a. So let b disappear. Now, what we have here is b times 2 minus x. So let 2 minus x equal 0. So if 2 minus x equals 0, we have to let x equal what? 2. So let x equal 2. See that? Let me rewrite that. Let 2 minus x equals 0 by letting x equal 2. If we make x equal 2, then b will disappear. So if x equal 2, what we have is 2 equal a times 3 plus 2. So it's a times 3 plus 2 plus b times 2 minus 2. Now notice what happened. 2 is equal to 3 plus 2 is 5. 5a. Right? b times 2 minus 2. But 2 minus 2 is 0. b times 0 is 0. So what we have is a is equal to 2/5. So now that we know a and b, we can write this the form a over 2 minus x, b over 3 plus x. So we have a over 2 minus x, b over 3 plus x. But a is 2/5. So the way we can write this, we could say 2/5 over 2 minus x, and b, what is b again? Negative 3/5. So we could say negative 3/5 over 3 plus x. Although the neater way to write it would be 2 over 5, 2 minus x, right? Then minus 3 over 5, 3 plus x, right? That would be the neater way to write it. I write this like this is not a multiplication sign, it's a plus. Alright. So here now, we've broken this thing up into its partial fraction. Right? Now we're going to integrate these things. But just before we integrate, let us check and see if it really is what it appears to be. Suppose we test this thing out. And we say 2 over 5 times 2 minus x minus 3 over 5, 3 plus x. We draw the line and find the LCM. It's 5, 2 minus x times 5, 3 plus x. 5 by 2 minus x into all of this is 5 by 3 plus x. 5 by 3 plus x times 2 is 5 2's 10, 3 plus x. You have to remember your fraction, you know. Minus 5 by 3 plus x into 5 2 minus x by 5 3 plus x is going to be 5 2 minus x. 5 2 minus x in by 3, it's 5 3 is 15, 2 minus x. We're just testing to see if we made any mistake and if it really works out. This will work out to be 10 3 is 30 plus 10x minus 15 2 is 30 plus 15x, right? So, this is going to be minus all of this over 5 2 minus x 5 3 plus x. So let's see, 30 minus 30 is 0. 10 and 15 is 25. So we have 25 over 5 2 minus x, and this is 25x. 10x plus 15x will be 25x over 5 by 2 minus x times 5 by 3 plus x. Right? Let's simplify this. We're going to have 5 by 5 down here is 25. So 25x over 25 times 2 minus x times 3 plus x. 25 cancel 25. So you have x over 2 minus x, 3 plus x. So it's x over 2 minus x, 3 plus x. Right, so it works out. It's correct. Alright. We're just testing it to make sure that everything is alright so far. And then we're going to integrate these things. So let's integrate them in one next video, or not necessarily. We could just integrate them now. Let's do it that quickly. Let's just do that quickly. We could do shortcut, but you could use a thing there, the substitution, to do them. Let's integrate it in this form, right? So this is 2/5 integral of 1 over 2 minus x dx plus negative 3/5 integral of 1 over 3 plus x dx. When you integrate these, shortcut, you have 2 over 5 times going to be ln of 2 minus x, and you divide by the derivative of 2 minus x, which is negative 1, so it's a negative here, plus, then, alright, you have minus 3/5 ln 3 plus x, and you divide by the derivative of 3 plus x here, and you will get 1 plus c. So that would be the answer, right? That would be the answer. As for the shortcut, remember, you have the integral of x, the integral of 1 over ax plus b, right? dx. Just a reminder how this shortcut thing works. Where I get the shortcut from, I mean, you let u, my gosh, let's put u equal, let u is equal to ax plus b. It's a use of the substitution. If you let u equal ax plus b, what you're going to get is integral of 1 over u dx. But you want to change the dx. You say the u by dx equal, du by dx is what? A. So a is the derivative of ax plus b. And dx would be du over a. So dx is du over a. And then you can see that this is the integral of 1 over a times 1 over u du, which would be same as 1 over a integral of 1 over u du. So what you have is this is equal to 1 over a ln u plus c. But u is ax plus b, so it's 1 over a times ln ax plus b plus c, which is ln ax plus b over the derivative of ax plus b plus c. So you see, the integral of 1 over ax plus b is the same as ln ax plus b over the derivative of ax plus b plus c. So the integral of 1 over 3 plus x is the ln 3 plus x divided by the derivative of 3 plus x. Alright? So that's where you get the shortcut from. But anyway, let's quickly review and by the steps. We are writing in the form a over x plus a plus b over x plus b. Step 2, multiply by the denominators. Step 3, let numbers equal x. Here is where you'll find a and b. And step 4, you integrate. Alright, so here again, we have x over a 2 minus x, 3 plus x. To break them up in their partial fraction, we have a over 2 minus x plus b over 3 plus x. If you multiply throughout by the denominator, the full denominator, 2 minus x, 3 plus x, you cancel out what you need. Then you substitute a number into a number for x so that you eliminate to wipe out a and wipe out b. So you do these. When you get your numbers, you do your integration. Alright? So that's that. I'll see you in the next video.